Hey guys, so this video is going to focus on applications of Pythagorean's theorem. So Pythagorean's theorem deals with finding an unknown side of a right triangle. So if you're not familiar with his formula here, his formula reads a squared plus b squared is equal to c squared, where a and b represent the legs of the triangle, which is the sides, these straight sides here, and c is always referring to the hypotenuse, the diagonal where this x plus 2 is. All right, so normally it doesn't matter what a and b are, just a and b is a is one side, b is the other side. Doesn't matter which one you assign for each one of those, just as long as one side is the a, the other side is the b, and then your hypotenuse here is always going to be c. So what we're going to have to do here is all we're going to have to do is take these given measurements here, the x plus 1, the x plus 2, the x, and we're going to have to plug them in appropriately into the formula so that we can solve it. Now, typically when working with this formula, you are given some of the information. You might know that one side is 10, another is 12, and you're finding the missing one. But this example here is a little bit different here. If we look at our sides here, our sides are expressions. We have x, x plus 1, x plus 2. So it's going to be a little bit of a twist to the Pythagorean's theorem. But essentially, it's still going to be solved the same. So I'm going to say that this side over here, the x, that's going to be my a. Right? So instead of a squared, I'm going to be plugging in that in and getting x squared. And that's going to be plus b squared. Well, my b is going to be x plus 1. And I need to square that. And that is going to equal to c squared. So my c here is the x plus 2, and then we will square that. So we need to we need to follow the order of operations as far as simplifying down this formula. We need to take care of all those exponents that we have there so that we can work with our equation that we have after that. So squaring everything, so starting here, x squared. Well, x squared, that's just x squared. We can take that out of the parentheses. Plus x plus 1 squared. So here we can either do the FOIL method to multiply it, or we can just distribute it. If you need to, you can write that out 2 times here and do x plus 1 times x plus 1 and multiply that out. So when we multiply that out, let's see, x times x is x squared. And then we're going to have a plus a 2x plus a 1, right? FOIL, x times x is x squared. O stands for outside, so that's 1 times the x, so that just gives us 1x. Inside also gives us 1x, and then last is 1 times 1, which is 1. Combine those two middle terms there, and we have the x squared plus 2x plus 1. If you need to practice doing this multiplication, look up one of my videos on multiplying polynomials. Otherwise, continuing on with our equation, this is going to equal x plus 2 squared. So again, here we're going to have to take x plus 2 times x plus 2. And we're going to have to multiply that out. So when we do multiply that out, we get x squared. And then we're going to get a 2x with another 2x there. So we're going to get a 4x, then plus 4 when we do last times last. So we've multiplied everything together, but now what we're going to have to do is we're going to have to do some simplifying here. We're going to have to move everything over to one side of the equation so it's set equal to 0. Because I see that we're working with x squareds here, that lets me know that this is going to be a quadratic equation. And when it comes to quadratic equations, we want everything together on one side of the equal side all set to 0. So what I'm going to do here is I'm going to move over this x squared by subtracting it away. X squared minus x squared cancels there, but I also need to subtract that away on the left-hand side, which will make those terms cancel. Okay, I'm also going to subtract a 4x on both sides so that when we do that, well, let's see, on the left-hand side, we can drop down that x squared. 2x minus 4x gives us a negative 2x, and then we can drop down that plus 1 that we have there. And this is going to equal to, let's see, we got rid of the x squares, 4x minus 4x cancels, but we still have that 4 hanging out over there. So now all we really need to do is subtract the 4 on both sides. And when we do that, we are left with x squared minus 2x minus 3 is equal to 0. So we have everything simplified. Now we can work on solving this quadratic equation. All right, so I'm moving this quadratic equation up here so that we can work on solving this. Now, there's typically 3 ways that you can solve a quadratic equation. You can factor it, you can complete the square, or you can plug it into the quadratic formula. We are going to factor this here. So we're factoring a trinomial with a leading coefficient of 1. We do need to check to see if there is a greatest common factor here, but we don't have that with this particular case. So we can go ahead and factor this. This technique I call reverse FOIL. So our first term is x squared, and our first positions here. First times first multiplies to get this first. The only way to get x squared is an x times an x. Then we move our attention to the last term, and we have a 3 there. The only way to get a 3 is a 1 times a 3. So a 1 and a 3 need to be in those last positions there. Then we need to focus on our signs. And there's this rule that says whatever sign the middle term has, the bigger number has to have it. So because our middle term is negative, I need to put the negative with the 3. Now, to figure out what sign my other factor has, we look at the last term here, keeping in mind that last times last gives me this last term there. The only way to get a negative when you multiply is if you have different signs. Remember those integer rules. Same sign is positive, different sign is negative. So because I have a negative here, I know that these signs have to be different. And since this 3 is already a negative, the 1 has to be a plus. So now that I have this factored here, what we're going to do here is we're going to use the zero factor property, which tells us that we can split these two factors up and set them each equal to 0. So we're going to split them up and pretend here that they're their own little individual equations. And what we're going to do is we're going to solve these one-step equations. On the left, if I'm going to solve that equation for x, all I have to do is subtract 1 on both sides. So x is equal to a negative 1. And on the right-hand side, I have to add 3 to both sides, giving me that x is equal to 3. All right, so we get a negative 1 and a 3. So what we're going to have to do here is just kind of think back for a second. We're finding a measurement of a triangle, a distance, how long this is. And when it comes to measurements, you cannot have a negative measurement. So if you do get a negative answer here, you have to throw that answer away. It's meaningless for this problem. We want the positive measurement here. So this says that x is 3. So I'm going to move that over here, and I'm going to erase part of the screen so we can finish this problem up. All right, so wrapping this problem up, we solved, we squared everything, combined like terms, got everything on one side of the equal side, and we factored our quadratic equation and got our answer. Now, x equals 3 is not our final answer. We need to keep in mind that this says find each measure. They want how long each one of these 3 sides is. So one side is equal to x. One side is equal to x plus 1, and the other side is equal to x plus 2. So what we're going to do here is we're going to evaluate, and we're going to plug that x equals 3, and we're going to plug that 3 in for each one of these. Starting with the first one, that one just has an x, and x equals 3. That's what we solved. So we can just substitute the 3 into the x. So that left side over here is a 3. For the middle here, we have x plus 1, so I'm going to plug in the 3 for the x, and then we have that plus 1 there, so 3 plus 1 is 4. So that means this bottom straight side over here is a 4. And so we have a 4 there, we have a 3 there. The only thing we have to figure out now is that hypotenuse, that diagonal. So plugging in 3 for the x, adding 2 to that, we get a 4. 5. So our hypotenuse is a 5. So after we figure out what x equals, we need to remember to go back and plug that in, because this problem wants each one of these sides. So always go back and make sure you are answering the specific question here, that you're not just boxing that 3 and like, I'm done. Otherwise, that is it for this particular video.